Okay, good afternoon, my dear students. Today we're going to have another virtual class for Math 6103. This is Calculus 2, and our lessons for today is all about the derivative one, which is under Module 7. So these are our objectives. At the end of this session, students will be able to understand the definitions of derivatives and use the rules for differentiation in computing for derivatives. So we have here the definitions of the derivative. In the first section, the last chapter, we saw the computations of the slope of a tangent line, the instantaneous rate of change of a function, and the instantaneous velocity of an object at x is equal to a. All required us to compute the following limit. So the instantaneous velocity of an object at x is equal to a is equal to the limit of the function of x minus the function of a divided by x minus a as x approaches to a. And with a small change of notation, this limit could also be written as the limit of the function a plus h minus f of a divided by h as h approaches to 0. So we call this one as a derivative. So here's the definitions of the derivative. The derivative of f of x with respect to x is the function of f prime x, and it's defined as the first function of x equal to the limit of the function of x plus h minus f of x divided by h as h approaches to 0. So we have the limit, the function of a plus h minus f of a divided by h as h approaches to 0 is called the derivative of f at a. So this is now our formula for the first derivative. So following our ways to call the derivative. F, or the first degree of x, the derivative of f with respect to x. Y prime, you have the y prime, dy dx, the derivative of y with respect to x, df all over dx, the derivative of f with respect to x. The derivative of f of x with respect to dx, or the derivative of dx of f of x, the derivative of f of x. So if we're going to look on this formula, these are the results of the first derivative. Okay? Lahat po yan ay first derivative. So note, dx does not mean d times x. dy does not mean d times y. dy dx does not mean dy divided by dx. df all over dx does not mean df divided by dx. The derivative of f of x with respect to dx does not mean d all over dx divided by f of x. So this represents that the derivative of the given figure is the slope of the original function. The derivative is defined at the end of points of a function on a closed interval. Figure 1, the derivative is the slope of the original function. So if we're going to look on our slope, we have your y is equal to the function of x. So this is our original function. Pag titingnan po natin, hindi pa siya nakuhanan ng first derivative. Pag first derivative na yan, that's what we call your y prime. Okay? So we have your example number 1. Find the derivative of y is equal to x squared minus 3. So this is now our solution. To find the derivative of the given expression, first, plug the function into the definitions of the derivative. Okay? So y prime, the limit of x plus h squared minus 3 minus x squared minus 3 divided by h as h approaches to 0. So, paano tayo nagkaroon ng ganitong equation? This is our formula. So, dapat wag tayong malito, no? So, we're going to replace your x by x plus delta h. Ito muna, no? This is our original function. Y is equal to the function of x. We're going to replace your x na ito by x plus delta x. And then minus your y, which is the function of x. Then divided by h as h approaches to 0. Okay? So dito, ganito po yung nangyari, no? So first, we're going to replace your x by x plus h. Ito na siya, no? So, nangyari po doon, yung x plus h, dahil squared siya, we have squared po. And then, minus 3. Ito po yung minus 3 niya. Okay? Yung x squared, nabago siya from our first derivative, x plus h, then squared minus 3. Then, minus, saan nakuha to? X squared minus 3, galing yan dito sa formula. Minus the function of x, which is equivalent to your y. Ito po siya. Y is equal to the function of x. So dito, this is now your y, which is the function of x, which is equivalent to x squared minus 3. Kaya nandito na siya. X squared minus 3. Then, divided by h as h approaches to 0. Okay? So next thing we're going to do is we're going to expand this one since we have a second degree using the square of the binomial. So if we're going to expand that one, a plus b raised to 2, we're going to have a squared plus 2ab plus b squared. Okay? So if we're going to follow that one, we have x squared plus 2xh plus h squared. Ito na po siya. Ito yung value po niya. X squared plus 2xh plus h squared. And then, if we're going to simplify this one further, so, didistribute natin yung negative sign dito. We have minus x squared. Then, minus 3, we're going to have plus 3. So, therefore, plus 3 minus 3, we're going to cancel. What's left will be x squared. Then, we have divided by h as h approaches to 0. So, we're going to have already your y prime. So, take note, pag nai-apply po natin na yung formula sa first derivative, that's the time that we're going to use or indicate y prime, which means we're already getting the first derivative. Okay? Next. So, y prime is equal to the limit of 2x plus h as h approaches to 0. Paano siya nagkaganon, no? So, dito, okay, if we're going to simplify this one, x squared, we're going to cancel then, no? Okay? If we're going to get the value, okay, collecting like terms, so ito magkakancel na po siya. And then what's left will be 2xh plus h squared. And then, if we're going to have the common factor here is h. So pag finactor yan will be h quantity 2x plus h. Then, therefore, yung h po dito, makakancel na po siya dito. Sa divided by h. So what's left will be 2x plus h as h approaches to 0. So since we already simplify our equation, next thing we're going to do is we're going to substitute our limit doon sa variable natin, which is h. So 2x plus 0 po siya. Now we evaluate the limit and get now the first derivative of x squared minus 3. The first derivative of that, y prime, is equal to 2x. Therefore, the derivative of x squared minus 3, that is your y prime, this is your y prime is equal to 2x. And 2x is what we call the first derivative. Okay? Next example, number 1. Another example, find the derivative of the function of x, which is equivalent to 2x squared minus 16x plus 35. Okay? So with that, the first thing we're going to do is we're going to first plug the function into the definitions of the derivative. So ito yung formula natin ng first derivative. The first function of x equal to the limit f x plus h minus f of x divided by h. Okay? So with that, again, we're going to replace your x by x plus h. Ito po siya, no? So yung x squared magiging x plus h and then squared. And then, minus 16x. So we're going to replace your x by x plus ulit, x plus h ulit. So minus 16x plus h, and then plus 35. Okay? So naayos na natin ito, this condition. Minus the function of x, our function of x is equal to your y, ito. The function of x natin is equal to 2x squared minus quantity 2x squared minus 16x plus 35, then divided by h as h approaches to 0. Okay? So next, we're going to simplify it again. We're going to expand this one using your square of a binomial. So from the formula, a plus b raised to 2, we're going to have a squared plus 2ab plus b squared. So your a represents your x, your b represents your h represents your b, no? So if we're going to expand this one, we're going to have x squared plus 2xh plus h squared. Yun po siya. Okay? So, then after that, we're going to distribute yung 2 doon sa expanded value nito. So, 2 by x squared, we have now 2x squared. Then, 2 by 2xh, we have 4xh. Then, 2 times h squared, we're going to have 2h squared. And then, for this one, distribute natin yon, we have minus 16x minus 16x. Ito na